here is your practice test, and you have the solutions for this on Canvas, but I also wanted to go through the questions with you as well to give you some explanation. So question number 1 is referring to this beautiful molecule right here, and it wants you to give it a name. I can see that this molecule is an aldehyde because it has the aldehyde functional group right there. So I know that its name has to end in Al for aldehyde, so it's not A or B. So the question then is, it looks like our choices here are, is it 1 or is it 4 butanal? So when we are coming up with the numbers for aldehydes, we start numbering at the position of the carbon-oxygen double bond and number our way out. And since the carbon-oxygen double bond is on carbon number 1, this molecule is 1-butanal. So now our next question, it says we're going to, for box 2 and 3 and 4, we're going to draw the structures of the products of these reactions. When we are reacting any double bond with H2, it doesn't matter if it's a carbon-carbon double bond or a carbon-oxygen double bond, in that reaction we are changing the carbon-oxygen double bond from a single bond, and we are adding a hydrogen to the carbon and the oxygen that were part of the double bond. Question number 3, we have 2 alcohol molecules reacting with our aldehyde. That's an acetal reaction, so we want to draw that aldehyde with the carbon-oxygen double bond opened up like a flower, and we are going to put the carbon chain from the alcohol, so that's a CH3. We're putting that carbon chain on the oxygens to give us an acetal. And then last but not least, Tollen's reagent. If you look in your notes, Tollen's reagent magically converts an aldehyde to a carboxylic acid by magically adding that oxygen right there. So questions 5 and 6 and 7 look pretty similar. First thing we have to do is name this molecule right here. I can see that it's a carboxylic acid. So the ending of this molecule's name needs to be ic acid. Ic acid. Looks like that just narrows it down to 1. All carboxylic acids' names will end in ic acid. With NaOH, NaOH will remove the hydrogen from the end of the carboxylic acid. So we're going to get something that looks like this. And on sapling, you've been well trained to include the sodium Na+ in there. But if you're looking at the solutions on Canvas, I didn't include that Na+ because it's okay if it's not included. It's all right if it's there. It's all right if it's not there. What about when we react a carboxylic acid with an alcohol? It's a pretty similar reaction. So we're removing the hydrogen from the OH, and we are replacing that hydrogen with the carbon chain from the alcohol, CH3. Next up, we have a molecule, and it asks us if it's an alpha or beta hydroxy acid. So to figure that out, we find the carboxylic acid. The carbon that it's connected to is alpha, and the next carbon over is beta. So this one, because the OH is on the beta carbon, it is a beta hydroxy acid. What are 2 correct statements about salicylic acid? Used in dermatology for the treatment of acne and warts. That is true. It can be extracted from willow bark. That's not true. That was not salicylic acid. It can be extracted from meadowsweet. Yes. Salicylic acid comes out of meadowsweet. So we have found the 2, so we're good to go. Let's carry on. The structure of nicotine is shown below. Classify both nitrogens. So when we're classifying a nitrogen, we are looking at how many bonds to carbon does it have? How many nitrogen-carbon bonds are there? We have 1, 2, 3 nitrogen-carbon bonds, so it's tertiary. This guy over here, we have 1, 2, 3, so it is also tertiary. Remember, a nitrogen-carbon double bond, that counts as 2. a nitrogen-carbon triple bond would count as 3 in this type of classification. True or false, takes a maximum of 2 weeks for the brain to repair after discontinuing nicotine use. That is false, spelled flas, false. False, that is true for caffeine. Caffeine is 2 weeks. Nicotine is about a year. Draw the structure of the product of the reaction between dopamine and hydrochloric acid. In this reaction, whenever we have any amine that is reacting with HCl, we are not making any changes to the molecule. So we've got the whole molecule drawn out just like normal. We are adding another hydrogen to the nitrogen, which gives it a positive charge. And on sapling, you're accustomed to writing the chloride ion with it. I didn't put that on the solutions. It's okay if it's left out. It's not really the most important part. Which statements about dopamine are true? There may be more than one. It's a neurotransmitter. Yes, it is. It's a messenger. Yes, neurotransmitters and hormones are messengers. It works with serotonin and norepinephrine to regulate mood. Yes. Slightly elevated amounts are associated with high. Yes, that's why we get high off of cocaine. Abnormal amounts are associated with schizophrenia and Parkinson's. Yeah, so they're all true. Which 2 of the following drugs are similar to epinephrine in terms of both the structure and metabolism? So epinephrine is going to be a stimulant. Methamphetamine is very similar to epinephrine, and so is albuterol. And you should find those in your notes for sure. Active transport requires energy to move ions from low concentrated area to high concentrated area. That is true. Draw all 4 products of the following reaction. Oh my goodness. So this is where we're going to be breaking one of the carbon-oxygen single bonds. And it's not going to matter which one you choose to break when you do this type of problem. So I squiggled the bonds that I'm going to break. So we've got a break there. And then I'm going to draw the other parts over here. CH2, 16CH3. And I'm going to make these little lines where I broke the bonds to help me remember where I broke the bonds. CH2, 18CH3. And our last one, CH2, 20CH3. The water that we're adding in this is going to get divided as a hydrogen and an OH. And so at every point, so starting up here, one of these bonds is going to get a hydrogen and one is going to get an OH. And our goal is to make OHs on the molecules. So this is what we make, just like that. Is the reactant in problem 16. So here's our reactant. Is our reactant soluble in water? That's a heck to the no. That's a fat or an oil, long carbon chain. Classify this molecule. Is it best described as a carboxylic acid or a fatty acid? This would be best described as a fatty acid because that is definitely a long carbon chain. And is it made in nature, yes or no? Well, it depends on how many carbon atoms it has. 2, 4, 6, 8, 10, 12, 14, 16, 18. It's probably made in nature because it has an even number of carbon atoms. For next question, classify the molecule in problem 18. Saturated, monounsaturated, or polyunsaturated. So saturated would mean that it only had single bonds between the carbons. Monounsaturated would mean that it had one carbon-carbon double bond, and I can see more than one carbon-carbon double bond, so it's polyunsaturated. Are the double bonds cis or trans? A cis double bond looks like this. A trans double bond looks like this. These are all trans double bonds. And then, label any 2 of the components of the lipid bilayer, any 2 that we want. Well, I can see this is pointing at the heads, the polar heads, and this line here is pointing at the tails. the non-polar tails. I can see the 4-ring structure here. That's cholesterol. And these guys right here are all proteins. These are the channels. This and this is stuff that we didn't have this quarter. So there is answers to this on the solutions, but they're not going to be familiar to you from the stuff that you've done this quarter.